Okay, we're here doing an Algebra 2 video. I'm Mr. Lucas. If you're one of my students, you should be watching this video after I've assigned it to you. As with the other videos, I would recommend strongly that you have your book open and you sort of follow along as we go, because I think that will help. I also recommend that maybe you take some notes. You want to have something written down to refer back to when we're working on this in class. Now, we're looking at section 1.3, which goes from pages 18 to 21 in your textbook. We're also going to be touching on 1.4. Now, section 1.3 and 1.4 have a lot to do with equations. We're going to be solving a lot of equations this year, so we're sort of reviewing how that's done. Now, an equation is a statement that two expressions are equal. In our last set of videos, we talked about expressions, numerical and algebraic, and we saw what they were. An expression is numbers or variables and operations. An equation says two expressions are equal. They are exactly the same thing. Now, equations are a balancing act. Anything you do on one side of the equation has to be done on the other side. If I tell you that two things are equal, and then you add something to one of them, they won't be equal anymore, unless you add the same thing to the other. And that's just logic. Now, what that means for us in math is that when we're trying to solve an equation, which is the goal for most of what we're doing, if we want to solve an equation, we're trying to get the variable by itself on one side of the equal sign, and we're trying to get a single number on the other side of the equal sign. The trouble is that when we're doing this, if we accidentally change one of the values and not the other, then our equation will no longer be true and we'll get the wrong answer. So it's very important that we always do the same thing on both sides of the equation. Now, typically when we're dealing with an equation that we want to solve, we want to do the opposite of whatever operation is being performed on the variable. For instance, in this equation, this is a one-step equation. There are equations that require more steps. In this one-step equation, the operation that is being performed on the variable x is multiplication. So we want to undo that multiplication. We undo that multiplication by performing the opposite operation. Now, the opposite of multiplication is division. So if I want to solve this equation, perform the opposite operation, which is division. And I'm going to divide by exactly the same number that I'm multiplying by. So I will divide by 2. Now, if I do it on the left side of the equation, as I was just saying, I have to do it on the right side of the equation to keep the two sides in balance. Now, I have 2x divided by 2. Anytime I have a fraction, in this case 2 over 2, where the same thing is on the top of the fraction as on the bottom of the fraction, they cancel out and become 1. So 2x over 2 becomes 1x, or just x. 4 divided by 2 is 2. So this equation, 2x equals 4, can be solved to be x equals 2. Some equations do require more steps than others. This is a two-step equation. It's a two-step equation because it requires 2 steps to solve. Two-step equations are solved the same way every time. We're pretty much always going to have a number that we're multiplying x by. Sometimes we'll be dividing, but most of the time we'll be multiplying x by a number. And we'll be either adding or subtracting something from x. In this case, we're adding 6. When I begin a two-step equation, I always want to start by either adding or subtracting every time. I will never want to multiply or divide first in a two-step equation. I will always add or subtract. Now, since I am adding 6, I want to perform the opposite operation. The opposite of addition is subtraction. So I will subtract 6. And again, if I do it on the left, I have to do it on the right, or else the equation will no longer be in balance. I have 6 minus 6 is 0. Cancels out. On the other side, 12 minus 6 is 6. So 3x equals 6. Now this is it has gone from a two-step equation to a one-step equation, which is solved the same way we solved the last one. We perform the opposite operation. In this case, we're multiplying x by 3, so we want to divide x by 3. If I do it on one side, I have to do it on the other, so I'm dividing. Now, sometimes I will multiply, but that is not as common as dividing. 3 over 3 cancels out and becomes 1, and I've got 1x. 6 divided by 3 is 2. So in this equation, just like in the last one, x equals 2. This equation and the equation before it are equivalent because x equals exactly the same number. Now this equation is a little bit more complicated. It's going to require several steps to solve. 2 times 3x plus 1 in parentheses equals 2x plus 10. Let's take a quick look at what we've got here. Now I've got a set of parentheses on the left side, 3x plus 1 in parentheses, with a number multiplying it. So I'm going to have to do distribution here at some point. And I also have an x term on the other side of the equal sign. Now my goal when I'm solving an equation, as I've said, is to get all the x's to one side of the equal sign. Anything I do has to go towards that goal of getting the x's to one side of the equal sign. Now, before I can move that x over, though, I have to distribute. So I'm going to get rid of these parentheses. I will always have to get rid of parentheses first if I'm dealing with an equation. So I distribute, I get 6x, 2 times 3 is 6, plus 2. Now, I have not changed the value on the left. By distributing, all I did was rewrite an equivalent expression. I did not change the value of it, so I don't need to worry about changing the other side of the equation. Now, I do want this 2x to be on the other side of the equal sign. The only way that I can move an x is to add or subtract. So I will subtract 2x. And I will do it from both sides. On the right, they will cancel. On the left, 6x minus 2x is 4x. Plus 2 doesn't change, and 10 does not change. Well, now this is a two-step equation. And I solve this two-step equation exactly the same way I solved every other two-step equation. I start by adding or subtracting, and then I divide or multiply. Since this is plus 2, I will subtract 2. So I have minus 2 on the left and minus 2 on the right. On the left, 2 minus 2 cancels out, and I'm left with 4x. On the right, 10 minus 2 is 8. So I have 4x equals 8. This is a one-step equation. I have to undo the 4 times x by dividing by 4. The 4's cancel, as we've seen before, and x equals 8 divided by 4, which is 2. And again, this equation happens to be equivalent with the other two because x equals 2 in all of them. Now, you can check your answers to an equation by substituting your answer back into the original. And we'll see how that's done with this example. I know this equation has a fraction in it, but I don't want you to worry about fractions. We'll see how they can be dealt with pretty easily with the calculators. We're going to start the same way. This is a two-step equation, so I'm going to subtract 8 from both sides. I have 4 over 5x equals 12. Now you notice that I put the 4 over 5 here in parentheses. And the reason I did that is because when I'm dealing with the graphing calculators that we use in class, they can handle the fraction just as easily as they can handle regular numbers, provided that you put parentheses around it. So that's what we're going to do. Now I need to divide both sides of this fraction by 4/5. I know it seems complicated, but if we're using the graphing calculators, it's actually fairly easy. If you don't have your own graphing calculator, there are apps for the iPad, iPod, and iPhone that will do the same thing. There are a lot of them. Some of them are even free. And of course, there are websites that do it as well. So, I divide both sides of my equation by 4 over 5. Even though they're fractions, they still cancel out on the left, and I'm still left with x. Now, 12 divided by 4/5, if I type it in, gives me 15. So x equals 15. And that's all well and good. All I need to do is substitute 15 back into my original equation. And I'm going to do that really quickly. Alright, let's say I've got 4/5 times 15 plus 8. Now, if x really does equal 15, then 4/5 times 15 plus 8 should equal 20. I type 4/5 times 15 into the calculator, and it gives me 12. 12 plus 8 equals 20, which is what the equation claims it is. So I had this question right. Now I want you to solve this equation on your own. I'll give you a second, pause the video, and then I'll show you the answer. Here we have the solution to this equation. All we have to do is perform the two operations, subtraction and then division, and we get x equals 3. If you didn't get this answer, or if you were confused when you were working it, make sure you make a note of it and we can talk about it in class. Let's move on to another one. Try this one as well. Now this one is a little more complicated, but only because it has a fraction. And as I've said before, the calculator can handle the fraction just as easily as it can handle anything else. We ended up with x equals -5. If that's not what you got, again, make a note of it and we'll talk about it in class. Double check your work, that you can see I've got here. You might be able to see where you made your mistake. Alright, one last one. This one has a lot of fractions in it. Don't be afraid, we are going to see a lot of fractions this year, so we're just going to have to get used to them. Okay, here we are. Now, I had to spread this one out a little bit because I wanted to write big enough for us to see. You can see we had to do some moving around, subtracting the 2/3 x, adding 1/2, and dividing by 1/3. So we had to perform a lot of operations with fractions. Again, with the graphing calculator, as long as the fractions are in parentheses, It really makes no difference whether you use numbers or fractions. Our answer here was 4 equals x. 4 equals x and x equals 4 are exactly the same thing.